A new kind of pickup is waking up under Texas steel and silicon.
Every finished truck here began as raw material, moving through a tightly choreographed industrial ballet.
The journey starts long before the first bolt is tightened, in the tonnage of steel waiting to be shaped.
Suspended in midair, raw material crosses the threshold into precision manufacturing.
Flat steel becomes potential geometry the moment it enters the beam of controlled light.
With micron accuracy, software-guided light scores the first lines of the Cybertruck's exoskeleton.
What was once a flat sheet begins its path toward the truck's distinctive folded armor.
In this cathedral of force, geometry is not draw, it is stamped into existence. Every contour here is intentional, a compromise between physics, safety, and radical design.
Before a single weld is fired, every panel must prove it conforms to the math.
Beside the stamped stainless shell, cast aluminum bones of the chassis form under crushing pressure.
Liquid metal becomes structure here, timed, measured, and compressed into a single massive casting.
One shot replaces hundreds of welded pieces, simplifying the skeleton of the electric truck.
Cast, cooled, and cleaned, these underbodies await marriage with the stainless exoskeleton.
This is where the truck's rigid shell and its cast spine lock together into a single structure. Sparks mark the last step of raw structure, before electricity and intelligence enter the frame. From here, raw metal will meet cells, motors, and software as the Cybertruck moves deeper into the heart of the factory.
The open belly of the stainless shell is ready to receive the power beneath. Thousands of cells ride in formation, waiting to turn chemistry into motion.
Millimeter alignment here determines how quietly power flows for years ahead. When every fastener hits its target, the chassis and its energy source become one. Compact electric motors replace the bulk of engines, yet still define how the truck pulls and climbs. These shafts and gear sets translate silent torque into the unmistakable shove of electric acceleration.
Color-coded conductors and coolant pathways keep high energy both controlled and cool.
Before the wheels turn, the truck must prove that its voltage is safe, sealed, and stable.
A new voltage standard reduces copper and complexity, but demands stricter precision at every connection.
Without a direct mechanical shaft to the wheels, electronics must carry the driver's intent faithfully.
Each corner is configured for the mix of utility, comfort, and off-road abuse that this truck is built to endure.
For the first time, the stainless triangle rests on its own footprint. Code enters alongside current, defining how motors, steering, and brakes will think.
Virtual miles are logged inside the factory before the truck ever sees a real road. Charging behavior is confirmed under controlled conditions long before customers arrive at a charger.
Stainless panels mean no paint chips, but sealing against water and noise still demands perfection.
Looks completely dry up here. Yeah, no moisture on the seals.
A dry cabin now allows the truck to roll forward into the precision of interior installation. The powered-up Cybertruck, now with pack, drive units, and rolling chassis complete.
Here, raw shells pick up the glass and trim that make them livable machines.
Before glass touches adhesive, any imperfection is caught while it is still easy to replace.
precision handling ensures a massive glass roof arrives perfectly aligned over stainless steel. Once seated and bonded, this panel becomes both a window to the sky and a structural element. With doors mounted, the vehicle transitions from an open shell to a recognizable cabin.
Panel gaps here are both a visual signature and an acoustic seal that customers will notice instantly.
Electrical vanes are laid down before the dashboard becomes the visible face of the cabin. This simple slab of glass will soon mediate nearly every command between driver and machine.
Seating anchors occupants to the battery and frame beneath, tying ergonomics to structure.
Storage pockets and trim details quietly decide how usable the truck feels day to day.
Each pane must move with just enough force to seal tight without damaging the glass or fingers. The truck's visual identity solidifies as its light signatures take their physical form. Every diode is proven under controlled darkness, so it will perform under real night skies.
Without paint to hide behind, stainless shows every error, so the light must be unforgiving. Small surface corrections keep the exoskeleton looking engineered instead of unfinished.
Stainless, glass, and energy now move as one, ready for the scrutiny of final tests. Away from the production roar, each truck faces its first personal examination. The factory now treats this truck not as a unit in a batch, but as a single traceable product. The relationship between feet and controls must feel consistent across thousands of different trucks.
Electronic steering still depends on a physical reference, a true, repeatable center.
Heavy weight and four-wheel steer demand tighter geometry control than a conventional pickup. The software can correct many things, but tire life still starts with physical angles.
Correct stance ensures handling, range, and aesthetics all match the design target.
Random audits and targeted checks keep small assembly escapes from turning into field issues. In an electric vehicle, any buzz or rattle stands out louder against the near-silent drivetrain. Fine-tuning here prevents future owners from chasing mysterious sounds down the highway. Vision systems need their own alignment, so software sees the world where it actually is.
Every sensor becomes part of a distributed nervous system, where one failure can break driver trust.
Heat is the quiet enemy of batteries. These tests ensure it can be moved and controlled. The digital fingerprints of assembly are wiped clean once every system reports healthy.
Consistent lines across hundreds of trucks are what separate industrial design from mere fabrication.
Rolling surfaces are sorted and confirmed, so early misalignment does not hide inside warranty claims.
Protective layers depart, so the finished surfaces can meet the world as intended. With initial sorting complete, the truck is ready to prove itself in motion. Cleared by the line, the truck now has to prove itself against real-world motion.
Straight-line acceleration checks confirm that hardware, software, and traction cooperate instead of fighting.
Measured deceleration distances tell engineers whether mass, tires, and brake tuning are in harmony.
Structured abuse here translates into smoother, less surprising moments for owners on real roads.
Aerodynamic efficiency shapes range, noise, and stability and was not obvious from its brutalist silhouette.
With new software and hardware,
One button alters the truck's posture for rough terrain. Climb and controlled descent prove whether mass, grip, and software can cooperate on steep grades.
Pressurized packs and sealed connectors are verified in conditions far more controlled than real floods. Sudden steering inputs show how well software and physics negotiate emergencies together.
Repeated stress reveals whether cooling systems can keep critical components within safe margins.
Charging metrics after heavy use help refine both software predictions and cooling strategies. Each test session ends with human eyes verifying what sensors may have missed. Every hard brake and sharp turn becomes data, feeding back into software that improves future builds. After proving its hardware on the track, the truck returns inside to receive its final brain.
Even inside the factory, updates arrive over secure links that mirror what owners will later see at home.
A silent handshake passes between dozens of modules before the truck declares itself ready.
This configuration step decides which capabilities are unlocked when the truck leaves the plant.
By the time it reaches final bays, its cameras already know how to see the road.
Small lines of code refine how each movement feels, from a steering twitch to a wiper stroke.
Profiles pre-configure comfort and controls, so test drivers spend less time adjusting and more time evaluating. Software also controls how the owner will see their truck virtually before any physical customization.
Autonomy is not a promise. It's part of the everyday logistics between bays.
The same capabilities intended for city streets first move the truck past its own assembly stations.
In this environment, autonomy failures are data points, not headlines. Autonomy hands the keys back to humans only after delivering the vehicle to its next staging point. Every uneventful autonomous trip here builds a silent safety record before owners ever engage it.
Outside the main building, software still choreographs the movements of hundreds of finished trucks.
Individual trucks become coordinated actors, each following a route through the same shared maze.
A central logistics brain monitors every unit, treating outbound movement as data, not guesswork.
Every vehicle's digital passport is reconciled before it moves onto shared transport. Mechanical restraint takes over once software has parked the truck exactly where it belongs.
Where rail doesn't fit the route, traditional carriers still bridge the last long gaps.
In some lanes, the trucks that move Cybertrucks are electric too, closing another loop in the ecosystem.
Outbound timing is tuned to reduce dwell, letting finished inventory move instead of sitting.
Even when production pauses, logistics keeps reshuffling the yard like a live puzzle.
Automation here runs long after most workers have gone home, shrinking idle time without burning overtime.